So this is problem 23, chapter 11, Giancoli 6th edition. So in this problem they give us, let's put everything that is given to us, the mass, all right. They give us the spring constant, so okay, and they say that this mass is struck by a hammer, so it gets speed, once we struck, and this initial speed is also given to us. Now this initial speed is the maximum speed, okay, because after that the part can only slow down. This mass can only slow down, okay? So we have the mass, we have the spring constant, and we get the maximum speed. That's how the motion starts, by giving to it a maximum speed, by giving to it a kick. And then comes a sequence of questions. The first one is determine the period. Determine the period. Well, do we have enough information? We do. Remember, the period doesn't depend on the amplitude. The period only depends on the mass and the spring constant. Okay, so we can go straight for the equation. The period is 2 pi square root of m divided by k. We have m, we have k, so we have the period. Part B. What is the frequency? Well, the frequency is just 1 over the period. Part C, the amplitude. How can we find the amplitude of this motion? Well, a good way is by using conservation of energy. I know that the maximum kinetic energy, and here I have all the information for that, is equal to the maximum elastic potential energy. So I have the mass, I have the speed, the maximum speed, I have k, we can find the amplitude. Okay, let's go for part. Actually, period and frequency, they are both part of A, right? What we just did here was part B. So part C now is the maximum acceleration. So when is the acceleration is maximum? Remember, this simple harmonic motion, the acceleration is not constant. It's very different from everything that we did in the first semester. So the acceleration is not constant. So there are points where it's maximum, there is a point where it's minimum, and values in between. When is it maximum? When the force is maximum. And where is the force maximum? When we are at maximum displacement, where we reach the amplitude, when the force is Ka. Okay, A here means the amplitude. But we know that the equation for the force is always Ma. At maximum displacement, at the amplitude, the acceleration, the force is maximum, so the acceleration is maximum. So from this equation here, we can find the acceleration because we have everything. K and M were given to us, and the amplitude we just found. Okay, now let's go for part D of the problem. Part D of the problem asks us the position as a function of time. So the position as a function of time is first the amplitude. So the amplitude you found here in part B, so just put your value here. Now you have to decide if you're going to use a sine or a cosine. Remember, we started this motion by kicking the mass, not by striking it with a hammer. That means we started this motion at the equilibrium position. So if we start at equilibrium position, remember that it's the sine of 0, the sine of times 0 gives us 0. We started at equilibrium position, so we should put sine here. Sine of 0 is 0, and we started at position 0. Sine of 2 pi and the frequency. Well, we found the frequency here. Okay, so put the number here. So here you can choose. Either you put the value just for the frequency, or you put this whole number. Put in your calculator 2 multiplied by pi, multiplied by frequency, and put that whole number. It's up to you. And this is multiplied by the time. And this is the equation. Okay, determine the total energy. That's the last question. The total energy, well, either we use the maximum kinetic energy, because we have all the information for that. We have the mass, we have the maximum speed, or you can also use the maximum elastic potential energy, because we have K and we just found the amplitude. So we are done with this problem. Not too bad.